Okay, let's look at the cos or the double angles, and we're going to prove that cos A plus B, or the cos of A plus B equals cos A cos B minus cos A sine B. So let's have a look at the way this is done, and we're going to look at it in two ways. This again is the unit circle. This over here is the point A cos A sine A. So this angle is A. That whole angle is A. And this point over here is cos B sine B. So this angle here is B. So that angle is B, and this whole angle is A. So this angle in the middle, the one that we're really after in this triangle, is A minus B. And let's look at the cos rule. And remember, this is the unit circle, therefore this is 1 and 1. So if we look at the cos rule in here, we know that x squared is going to equal 1 squared plus 1 squared minus 2bc, which is just 1 times 1. And then we're going to times it by the cos of A, or the cos of our angle. And our angle in this time is A minus B. So what we get is that x squared equals 1 plus 1, which is 2, minus 2 times 1, which is minus 2 times cos A minus B. And we're going to use that formula later on, but that's the first one we're going to get. Now we're going to do exactly the same thing, so it's exactly the same diagram. This is our 1 point, this is our another point. We're on the unit circle, so this is 1, 1. This angle here is the cos of A minus B again. But this time we're going to look at the distance formula, and we're going to look at the distance formula between these 2 points. So how do we find the distance? It's going to be x equals the square root of x1 minus what? x2. So cos A minus cos B, and we're going to square that, plus sine A minus sine B, and we're going to square that. And we're going to try to simplify this as much as possible and get something that we can work with. So what we get is that x equals, or x squared, squaring both sides because I don't like the square root sign, we get cos A minus cos B all squared plus sine A minus sine B all squared. And the next obvious step here is to expand these brackets. So we're going to get x squared equals, it's a square, so that's going to be cos squared A minus 2 times the product, 2 cos A cos B, plus cos B squared, or cos squared B, plus and we're going to get exactly the same thing except sines over here. So we're going to get plus sine squared A minus 2 sine A sine B, plus sine squared B. And that looks fairly horrible, but let's start simplifying it if we can. So we get x squared equals, let's look at this cos squared A, plus, and we'll take this sine squared A next to it. And we've got cos squared B, and we should have a sine squared B, which is nice. And then we've got minus 2 lots of cos A cos B, minus 2 lots of sine A sine B. Okay? Now, the nice thing about that is that cos squared A plus sine squared A, well, that equals 1. Cos squared B plus sine squared B equals 1. So we're starting to simplify this down a fair amount. Remember, it's on the unit circle, and that's the whole reason why that cos squared A plus sine squared A equals 1. We look at that little right angled triangle up here. We know that cos squared A plus sine squared A is going to be 1, the radius of that right angled triangle. So what we've got is x squared equals 1 plus 1 minus 2 lots of cos A cos B minus sine A sine B. And the really nice thing about that is if I simplify it, we get x squared equals 2 minus 2 lots of, oh, hang on, we've just lost light. two lots of cos A cos B minus sine A sine B. And if we look back at this other formula here, it's pretty much the same formula. This is what we had. We had x squared equals 2 minus 2 lots of this. Here we've got x squared equals 2 minus 2 lots of this. So that lots of this, if we look at these two formulas, and I'll write the other one so you can see it on the same page. And for those people that have been watching carefully, did I stuff up? If I take minus 2 out, this should become a plus, and this should become a plus. So what we get is that the cos of A minus B equals this thing. So that's how we get our formula. The cos of A minus B equals cos A cos B plus sine A sine B. So just going over that little mistake that I made. When we take minus 2 out the front here, when we take minus 2 out, we're going to get a positive cos A cos B and a positive sine A sine B. So that's the little proof of why cos A minus B equals cos A cos B plus sine A sine B. To go from there, because that's what cos A minus B equals, it'd be nice to know what cos A plus B equals as well. So let's have a look at rewriting this. Instead of cos A minus B, let's do cos A minus minus B. And what happens when we put minus B in instead of B? Well, one thing I know is if we look down on the cos curve, cos of B equals cos of minus B. This is B, this is minus B. This is B, this is minus B. So what we know is that cos of minus B equals cos of B. And we're going to use that. And what do we know in the sine curve? Well, if this is B and this is the sine of B, then this is the sine of minus B. So in the cos curve, this is B, this is the sine of minus B. So in the sine curve, it's the opposite. The sine of minus B equals minus sine B.
It's the entry desk.
This is the entry desk.
Register. Yeah.
That was a teacher, not a student, so we can't really go rouse on him, but you know. So if we substitute into our formula here, what we get is the cos of A cos of minus B plus sine of A sine of minus B. And what did we just say? This doesn't make any difference. So we just substitute into the formula. Instead of B, we put minus B. Instead of B, we put minus B. What did we just say? That the cos of minus B equals cos B. So we get cos A cos B. And what was the sine of minus B equals minus the sine of B. So that's how we get that second formula. And I might just leave it there. Thank you.
Oh, sorry, I didn't know you were.
Oh, no, that's okay.